You know that little shock you sometimes get when you touch a doorknob? That tiny zap? Well, that's an invisible force called an electric charge. But what if I told you there's a simple, kind of magical tool that lets us see that invisible force? That's right. Today, we're going to dive into the electroscope.
I mean, just think about it for a second. That weird static cling you get in your clothes, or when your hair stands up after you pull off a hat, all of that is caused by this invisible force. It's literally all around us. So the big question is, if we can't see it, how on earth are we supposed to study it?
Okay, so that zap from the doorknob, that proves the force is real, right? You can definitely feel it. But just feeling something isn't quite good enough for science. The real trick, and this is the big question we're tackling today, is how do we go from just feeling this thing to actually seeing what it's doing?
And here it is. This is the answer. Meet the hero of our story today, the electroscope. Now, it might look pretty simple, but trust me, it's a super clever piece of tech. Its whole job, its entire purpose, is to be a visual detector. To answer one simple question, is there an electric charge here? Yes or no?
So, what's the secret? How does this thing actually work? Well, to figure that out, we've got to look inside. Let's take a closer look at all the different parts. You'll be surprised how simple it is.
The design is honestly super basic. At the very top, you've got a metal knob. That knob is connected to a metal rod that goes straight down. And that rod goes down into a glass case where you'll find two really thin pieces of gold foil. We call them leaves. The glass case is just there to protect those super delicate leaves from things like the wind. And that's basically the whole thing.
So when nothing is happening, when it's just sitting there, the electroscope is electrically neutral. That just means there's no extra charge anywhere on it. And because of that, the two little gold leaves just hang there, straight down, touching each other, not moving at all. You can think of this as its starting point, its off position.
All right, you're ready? This is where the magic happens. Let's bring an electric charge into the picture and see what goes down. This is the moment we've been waiting for, where the invisible finally becomes visible. So, how do we actually get those leaves to move?
So imagine you've got a plastic rod and you've given it a negative charge. Now watch this. When you touch that rod to the metal knob on top, the charge doesn't just stay put. Nope. Metal is a conductor, which means that negative charge flows like water, straight down the rod and spreads out over both of the gold leaves. And bam! That's when you see it. The leaves instantly jump apart.
But why? Why do they suddenly fly apart like that? The answer is one of the most important rules in physics. Like charges repel. That means they push away from each other. So two negative charges will always push each other away. It's kind of like trying to push the same ends of two magnets together. You know how they fight you? They just refuse to touch. It's the exact same idea.
So since that negative charge went to both leaves, they now have the exact same charge. And what do things with the same charge do? Exactly. They push each other away as far as they can get. And that movement, that's it. That's the visual proof we were looking for. We can now literally see the evidence of that invisible charge.
But wait, there's more. The electroscope has another cool trick up its sleeve. You see, just detecting a charge is pretty cool. But what if we want to know what kind of charge it is? Well, this little device can actually help us figure out if a new mystery charge is the same as the one we already have, or if it's the opposite.
Okay, so let's set up a little experiment. Picture this. Our electroscope is already charged up, so the two little leaves are spread apart. Now, we're going to bring a new object with a charge we don't know close to the top knob, and all we have to do is watch what the leaves do. Their reaction is going to tell us everything.
This is the really clever part. Let's say our electroscope is already negatively charged, okay? So if we bring another negatively charged object near it, well, that new object pushes even more negative charge down into the leaves. They get extra negative, and so they push apart even more. They spread out wider. But what happens if we bring a positive object nearby? Well, positive attracts negative, right? So it pulls some of those negative charges up out of the leaves and toward the knob. With less negative charge down there to push them apart, the leaves can finally relax a bit and move closer together. It works perfectly, every time.
So let's do a quick recap of what we've learned. The electroscope, it's a simple tool, but it's a really powerful charge detector. And it all works because of one basic rule. Like charges push each other away. By just watching the leaves, we can see if a charge is there. And even better, we can tell if a new charge is the same as the old one, because the leaves will spread even wider, or if it's the opposite, because they'll move back together. Simple as that.
And you know, that kind of leads to a much bigger idea, doesn't it? I mean, with just a metal knob and a couple pieces of foil, we figured out how to make an invisible force of nature totally visible. It really makes you wonder, right? What other invisible forces are out there, all around us, just waiting for someone to invent the right clever tool to finally let us see them?